Hello, and I'm a quick person again, Elective ICT, and then this is hardware component 2, meaning there's hardware component 1. And like I said in hardware components 1, going forward, my videos have to be within 30 minutes or slightly over 30 minutes. So I'm going to divide them in parts, depending on the subject or the topic. I mean, you can have part 1, part 2, part 3 in that order. My email still remains quickboysensitive@gmail.com, and then my website still remains anyway.triple0.com. Without wasting much time, let's get into tutorials or today's tutorials. All right, so lesson quotes. Our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. Our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. Thomas Alva Edison said this, and Thomas Edison, a popular person, the light bulb man. So if you don't know Thomas Edison, you can just refer to him as the light bulb man. But yes, an inventor, an American inventor, was an American inventor, and then a businessman as well. So he did things in electric power generation, mass communication, sound recording, and motion, other things as well. Thomas Alva Edison. The lesson objectives. At the end of this lesson, the student should be able to identify the main part of the central processing units and then describe the processes involved in the machine cycle. Now, main part of the central processing units. So the CPU, the central processing unit of a computer, is a piece of hardware that carries out the instructions of a computer program. It performs the basic arithmetic, logic, and input and output operations of a computer system. Some examples are Intel, AMD, Qualcomm, Snapdragon, etc. You know the CPU as the brain of the computer, and as the brain of the computer, then you surely do know that it does a lot of work. You can use your brain, or yes, your brain as an example. You do a lot of processing. Depending on what you're processing, the parts of the brain you use in doing that. This is no different from the computer or our system unit or our mobile phones. Our mobile phone needs to do some processing. Our desktop computers need to do some processing. And the device or the component that helps us to do this processing is a central processing unit. And the central processing unit, we have examples, we have Intel. But when you say Intel, you mentioned everything. So it is always better or appropriate to break them down. So we have Intel Celeron, we have Intel Pentium, we have Intel Silver, and I think there's Intel Gold as well. Then you come to AMD. We have AMD Athlon. Then Qualcomm Snapdragon, and then Samsung Exynos. However, for Qualcomm Snapdragon and Samsung Exynos, they are mobile phone CPUs. So if you are asked to give some mobile phone CPUs, you are looking at Qualcomm Snapdragon or Samsung Exynos. But for desktop computers or laptops, they are looking at Intel and then AMD. And I said we have AMD Athlon, we have Intel Celeron, Intel Pentium, Intel Silver, and other Intel CPUs as well. So this CPU has parts. Okay, it has parts, but the main parts are the control units and then the arithmetic and logic units, or the arithmetic logic unit. It has other parts as well, and then it registers, or the other parts are registers, cache, buses. Now the control unit. So the control unit, like its name, and then when we look at hardware components one, we discuss or we look at the control unit. However, the control unit fetches, decodes, and executes instructions. These are the functions that the control unit perform. It fetches, decodes, and executes instructions. It also issues control signals that control the hardware. Further directs these control signals between the CPU input and output devices. It also moves data around the system unit. So the control unit, a part of the CPU or a main part of the CPU, does this following functions, or the functions you have there or you can see on your screen. Then arithmetic logic unit. Again, we don't have arithmetic unit and then logic unit. It is one unit, arithmetic logic unit. However, arithmetic is mathematics and then logic is decisions. So yes or no, true or false, greater than equal to some, greater than or less than equal to, and all of that. They need logic, and then arithmetic, you have your plus, minus, your multiplication. Yeah, so the ALU performs arithmetic, which is mathematics, and then logical operations, decisions. The allo is where calculations are done and where decisions are made. The second function, or it acts as a gateway between primary memory. So by primary memory, you're looking at a RAM or ROM, and secondary storage. By secondary storage, you're looking at your hard disk or optical disk, like CDs and DVDs or flash drives. Then data transfer between them passes through the allo. Then registers. So registers here are part of the CPU, but they are not the main part of the CPU, so other parts of the CPU. The registers are small amounts of high-speed memory contained within the CPU, used by the processor to store small amounts of data that are needed during processing. So during processing, there are small amounts of data that are needed, and such data are the address of the next instruction to be executed. When we look at the machine cycle, how the CPU works, you would come across this, the address of the next instruction to be executed. Well, I will explain that when we look at it. Or better still, let me even talk about it. So the fetch operation handles the address of the next instruction to be executed. And then this is stored in the register. Then the current instruction being decoded was also stored in the register. Then the results of the calculations or results of calculations or everything that has been done is also in the register before it is written back to memory. So yes, the register, a small amount of high-speed memory contained within the CPU, used by the processor to store small amounts of data that are needed during processing. And I'm saying that a small amount that are needed during processing are the address of the next instruction to be executed, the current instruction being decoded, and then the results of calculations. The register has types, and then one, you have memory address register, memory data register, memory buffer register, accumulator, program counter. And with the registers or the types of registers, it's beyond the scope of the subject, the elective ICT course. So I won't go into details. However, you are free to do some research on it and understand them. Buses. A bus is a high-speed internal connection used to send control signals and data between the processor and other components. Don't forget that bus is also part of the central processing unit and other buses or system buses. And then I'm saying this because in hardware components, one is system buses. So system buses or buses, they are the same thing, or they are used, or you can interchange the system bus or buses. And a bus, as part of the CPU, is a high-speed internal connection used to send control signals and data between the processor and then other components. You have types, you have the address bus, you have the data bus, and then you have the control bus. And again, I talked about this in hardware components one, so I won't go into the details of it. Then you have cache. Cache is also part of the CPU. So a cache is a small amount of high-speed random access memory built directly within this processor. It is used to temporarily hold data and instructions that a processor is likely to reuse. So cache holds data and instructions that are frequently called upon by the CPU. This is done to enable the CPU work faster because the CPU will go through the RAM to do that if there was no cache. But since there is cache, the things that are instructions that the CPU has worked on before, CPU quickly goes to cache, sees them there, and then work on them. This affords the CPU enough time to do processing and cater for other tasks as well, rather than going through the memory anytime it wants to process an instruction. It gets it from there, processes the instruction, gets back to it. So yes, the cache is helpful and it's very good. And it's just a small amount of high-speed random access memory built directly within the processor. It is used to temporarily hold data and instructions that the processor is likely to reuse. And the next one that we have to look at is the machine cycle, or basically how the CPU works. Don't forget that I've told you that when you boot your machine, the CPU processes instructions or instructions, processes that the processing of instructions, still you shut down your machine. So it goes through some series of steps or sequences to perform instructions. And then these steps or sequences that the CPU goes through is what we are referring to as the machine cycle, or basically how the CPU works. So the CPU works in 4 simple steps, and the first one is fetch. So with fetch, the CPU reads the instruction or the next instruction from memory. The CPU reads the next instruction from memory. Don't forget that I said anything you want to do or any application you open, whatever the CPU needs to work on is first sent to memory. So the CPU reads that instruction from that place. So that is the fetch operation. So how the machine works, the cycle that the CPU goes to perform its work, when you type 2 times 2 on your calculator, before you see the results 4, is what I'm explaining to you, that the CPU goes through some processes or some sequences or some steps before giving you the results that you see on your screen at the end of the day. And the first sequence or the first step is fetch. And fetch here means that the CPU reads the next instruction from memory. After reading the next instruction from memory, it paves way for the next cycle, which is decode. Now, with decode, the instructions that were read from memory is translated into a language the CPU understands. So with fetch, the CPU reads the next instruction from memory. Now, the instruction that has been read from memory is translated into the language that the CPU understands. So decode here means that instructions that have been read from memory or instructions that were read from memory are translated into a language after the CPU is done translating the instruction is fetched from memory into a language it understands, which is zeros and ones. It paves way for the next cycle, which is execute. Now, with execute, the instructions that were fetched from memory and were translated into a language the CPU understands are worked on. So the execute stage, the instructions that were fetched from memory and has been translated. So with execute, the instructions that were fetched from memory and have been translated are worked on. So this is where arithmetic logic comes in. If the instructions that were fetched from memory are arithmetic based, then arithmetic unit does that. If it is instruction that needs a decision to be taken, then you're having the logic unit also doing that. So arithmetic logic units, depending on the instruction, one of them take over. That is arithmetic logic unit. So with execute, the instructions are being worked on. Once the instructions are done working, or once the CPU is done working on the instructions, it gives it to the next cycle, or it paves way for the next cycle to take over, which is store. And then this is the final stage or the final operation in the machine cycle, or how the CPU works. Now, the results of the processed instruction, or the results of the instructions that were worked on, or that have been worked on, is stored or written back to memory. It is written back to memory. So first, that is fetch. The CPU reads data or reads the next instruction from memory. Decode, the instructions that were read from memory are translated into a language the CPU understands. Execute, the translated instructions are worked on. If it is arithmetic, arithmetic is unit does that. If it is logic, that's decisions, the logic unit also does that. Then store, worked on instructions, or the results are written back to memory. This can be arranged and pronounced as feeders. So fetch, decode, execute, and chance. Also, so we've come to the end of another tutorial. So don't forget to check the description of the video. I'll put everything you need there. Try the hands on the following questions, or the questions that you have or you've seen on the screen. Don't forget, you can email me, you can leave comments in the comment section, and then I'll reply. Don't forget to subscribe and tell another person, for that person to tell another person, that the Anti-Dote series is here, and it's all about Elective ICT. Our next tutorial will be on data representation. Subscribe and keep the channel active. Until then, it's bye for now.